Hello everyone. In this video, we'll be deriving the equations of the kinematics for the constant acceleration and we'll be doing numerous good questions over that. Our target is all these equations. We'll derive them one by one. So as usual, you can take out your notebook and pen, and wherever you require, you may pause the video for making the notes. For better conceptual understanding, you'll be getting few checkpoints in between the video and their answers can be verified at the end of this video. Okay, so let us begin. Actually, the motion has an especially simple description whenever the acceleration is constant. So let's start the calculations. Acceleration can be written as d by dt of the velocity. You remember that? So here we can write dv is equal to a dt. Simple thing. We are doing indefinite integration both sides. Since acceleration is constant, so I have taken it outside of the integration. Since it is indefinite integration, the result will carry some arbitrary constant c. Our task is to determine the value of this arbitrary constant c. For that, let us assume a condition. At t is equal to 0, let's say we indicate the velocity vector as u vector. Getting it? And put it in equation number 1. So at the place of v vector, we are putting that u vector is equal to a vector and the moment of time has been taken as 0 plus c. So from here we get the value of c. This value of c I am putting back in equation number 1. It indicates that u vector is a constant. Getting it? Put value of c in equation number 1. So the equation number 1 will look like v is equal to at plus u. Okay, or you can write this in a familiar format, v is equal to u plus at. This is the first equation of kinematics. Whenever the acceleration is constant, then velocity at any moment of time can be obtained using this relation. Clear? Might be you have seen this derivation using the graphs. This derivation can be done in numerous other ways. Okay. After this, we'll be deriving the second equation of motion. So for that, we'll take this equation again. This v can be written as d by dt of the position. So I'm writing that here. D by dt of r is equal to u plus at. Do you agree? Here we can write dr is equal to u plus at dt. Now this time I'll be doing the definite integration. So for LHS, the lower limit is r initial and upper limit is r final. And in RHS, u is a constant, so I'll take it outside of the integration. The limit of time varies from 0 to t. At t is equal to 0, the position is r initial. At t is equal to t, the position is r final. Okay. Plus acceleration is a constant, so it will be taken outside of the integration t dt and the limit is from 0 to t. Fine. Let us integrate it. This will be r final minus r initial is equal to u integration dt. When you simplify it, only result here will be t plus a t square by 2. This r final minus r initial, do you remember something? Change in position. Change in position we indicate by the displacement. For displacement, I am using here this symbol s vector is equal to ut plus half at square. This is another familiar equation to you. This equation gives us the displacement of the particle for the time interval 0 to t. Okay. This equation has few more useful formats. I am writing them one by one. Displacement can be written as vt minus half at square. You can utilize this equation when you know the final velocity when you know the acceleration. Okay, this equation is used when you know the initial velocity, when you know the acceleration, when you know the time. Another useful format is this: displacement is equal to u vector plus v vector divided by 2 into t. This is the average velocity. Here is a nice trick. Whenever the acceleration is constant, then average velocity for any time interval will be equal to the initial velocity at the beginning of that time interval plus the final velocity at the end of that time interval divided by 2. Getting it? So you may note down this equation also, and then we are proceeding for the third equation of the motion. Starting the derivation for the third equation. If a particle is moving along the x-axis, we know that its acceleration is written as v dv by dx. Here v dv can be written as a dx. Do you remember? Let us integrate both sides. Let's say the x initial is the lower limit, and at x initial the velocity is u. X final is the upper limit, and at that location the velocity is v. We know how to integrate it. Its answer will be v square by 2 minus u square by 2 is equal to a times x final minus x initial. Okay. For a particle moving along the x-axis, x final minus x initial will be indicating the displacement. So I am writing the same equation in a simpler format. V square is equal to u square plus 2a delta x. Clear? Any doubt in that? Okay, fine. This equation can be also written in the vector form. If you require, v square can be written as v vector dot v vector, u square can be written as u vector dot u vector plus 2 times a vector dot del x vector. Okay, so here are the three important equations of the kinematics. Here v indicates the final velocity, u indicates the initial velocity, and a indicates the constant acceleration. The initial and final, they are dependent on the time interval. Suppose you are studying the motion from t is equal to 2 second to t is equal to 10 second. Then velocity at t is equal to 2 second will be taken as the initial velocity, and velocity at t is equal to 10 second will be considered as the final velocity. Clear? You may note down all these equations and then we'll be deriving the next equation. Now we'll be deriving an equation for the displacement in the nth second. Pay extreme attention to the word displacement in the nth second. For example, suppose a car is moving with the constant acceleration and someone asks you what is the displacement of car in the third second. How you can derive that? It's simple actually. Use the equation s is equal to ut plus half at square and find the displacement of the car from t is equal to 0 to t is equal to 3 second. Getting it? Then again use the equation s is equal to ut plus half at square and find the displacement of the car from t is equal to 0 to t is equal to 2 second. Clear? Now subtract the equation 1 and equation 2. Then you will get the displacement in the third second. Okay, simple calculation. So let's start it here. First of all, we will obtain the displacement in the time interval t is equal to 0 second to t is equal to n second. That displacement we indicate as Sn is equal to un plus half an square. Let's call it equation number 1. Then we'll be obtaining the displacement in the time interval t is equal to 0 second to t is equal to n minus 1 second. This we will indicate as Sn minus 1 is equal to u n minus 1 plus a by 2 n minus 1 whole square. Let's call it equation number 2. Our target is the displacement in the nth second. These two things are important, the displacement as well as the nth second. So we can obtain it using this computation, Sn minus Sn minus 1. Do you agree? Okay, let's do the calculation here for the displacement in the nth second. Sn is already available to us, un plus an square by 2 minus Sn minus 1. So writing this, un minus u into 1 plus a by 2. This is n square plus minus 1 whole square, okay, minus 2 n 1. Do you agree? Simple computation. Let us simplify the things here. Un plus an square by 2, taking this minus sign here, so minus un, this will become plus u1 minus a by 2 n square, this will become minus a by 2 into 1 square, minus 1 square and 1 square, they are same thing actually, plus a by 2 into n into 1. Do you agree with this computation? Pause here and check it carefully. Okay, then we can proceed further. un is getting cancelled out, an square by 2 is also getting cancelled out. Then what we are left with, u1, and this a by 2 I am taking common, so a by 2 2n minus 1 into 1. Pay attention, with this 2n there was a 1, here is that 1, with this 1 square, 1 and 1 here. I hope you understand. You might be thinking why I am carrying the 1 again and again. Just wait for a moment, you'll understand it. You might be tempted to write it in a simple format as u plus a by 2 2n minus 1. This is what you are thinking. That's absolutely fine, no issue in that. This is the displacement in the nth second. Now pay attention to this equation. Displacement in nth second will have what SI unit? Displacement will have the unit meter, SI unit meter. And now if you use this format, then you will have the unit of the initial velocity as meter per second, unit of acceleration as meter per second square. The units of an expression in LHS and RHS in physics, they should be same or different. What do you think? Actually, if there is equality, then units in LHS and units in RHS must be same. Simple thing. This equation is giving us the impression that here units and here units are different. Getting it? Many students have the misconception here that this equation is dimensionally wrong. Actually, this equation is dimensionally correct because the true format is this. For our simplicity, we are writing it like this. And if you check the true format, it is dimensionally correct. It is correct unit wise. You check it. The unit of u is meter per second. And this 1 is actually 1 second. Pay attention here. This is actually 1 second. So its unit is second. Second and second getting cancelled out. This is meter. Acceleration has the unit meter per second square. This n has the unit second. This 1 has the unit second. This 1 has the unit second. Second minus second. Some 10 second minus 1 second. So this unit will be effectively second only. Second into second is second square. This second square will get cancelled out. So here also we will be left with the meter. So the units in LHS and RHS are same. So you should not have that misconception that this equation is dimensionally wrong. This equation is dimensionally correct. For calculation purpose, we will be using this simple format. Okay. Another important thing about this equation, this n or this n is an integer or can it be fraction? Post your answer in comment box. This n must be an integer or it can be a fraction. What is your opinion? The correct answer is n can be fraction, because in the derivation nowhere we considered that n must be integer or n must be fraction. We took n as a simple variable. So n can be fraction also. For example, if someone asks you what is the displacement of a car in the 3.7th second, I want to say this thing. Displacement of the car in the 3.7th second. Actually, you can use this equation. Here you can put n is equal to 3.7 second. And this calculation will give you the displacement of the car for the time interval 2.7 second to 3.7 second. Getting the idea? Okay, you can note down this format and then we'll go further. I would like to derive the displacement in the nth second using the integration. This method is a bit quick. Just pay attention. Those who are good in the integration, they'll immediately understand it. Can we write dr by dt is equal to v? Okay. And when acceleration is constant, v is written as u plus at. Is it fine? So here we can write dr is equal to u plus at multiplied with dt. Simplifying it further, u dt plus at dt, and here is the dr. Let us integrate it both sides. Acceleration is constant, so taken outside of the integration. Initial velocity u is a constant. I derived it in the previous derivation, so it is also taken outside of the integration. The lower limit of the time we consider as n minus 1 second, and this position we call as Rn minus 1, and the upper limit of the time we consider as n, and this position we indicate as Rn. Suppose you need the displacement in the 6th second, then n here is 6 and this is 6 minus 1 means 5. So actually this equation will give you the displacement in the time interval 5 to 6 second, means the displacement in the nth second, displacement in the 6th second. Getting it? Let's do the computation. This will be Rn minus Rn minus 1 is equal to u, and here will be n minus 1. I have placed the upper limit as well as the lower limit, plus a, and this will be n square by 2 minus n minus 1 whole square by 2. This will be known as the displacement in the nth second. So I am indicating as s nth, and since we have already simplified it in the previous part, so I am writing the direct answer. You can check it yourself. It will come out to be u plus a by 2, 2n minus 1. And this equation is dimensionally correct. Just for sake of simplicity of the calculations, we represent it in this manner. With the u, here is actually 1 second multiplied, as well as here also 1 second is multiplied. I am not showing that here. Okay. If you wish, you may note down this way of doing the calculation or deriving the equation, and then we'll be taking up the questions. And keep one thing in mind, all these equations of the motion, they are valid if and only if the acceleration is constant. Then note down all these things. Here is a nice conceptual question. We have few expressions relating the position, time, the velocity and the time, the velocity and the position, acceleration, time, everything. Okay. And we need to find for which of these situations the equations of the kinematics for the constant acceleration are applicable. When the equations are applicable, what was the condition? Whenever the acceleration is constant, the equations of the kinematics for the constant acceleration are applicable. You know that concept. Give it a try. Pause the video here and try all these quickly and then post your answers in the comment box. I'm waiting for your answers. Okay, let's check the solutions. Looking at the first expression, the position is given. From this position, can we obtain the velocity? D by dt of x. That velocity comes out to be constant. If velocity is constant, it means the acceleration is 0. Acceleration is 0 means acceleration is constant, and whenever acceleration is constant, we can easily use all these equations. So equations of the kinematics for constant acceleration are applicable here. Done. Next, look at this. If you differentiate it with respect to time, v is equal to d by dt of x, then you will get minus 15t square plus 8t, and when you differentiate it again, then a is d by dt of v, which will come out to be minus 30t plus 8. Here acceleration is a function of time. If acceleration is a function of time, it means the acceleration is variable. If acceleration is variable, the equations of the kinematics for constant acceleration cannot be used. Then if you want to solve anything related to such a situation, what you will do? We can use integration, we can use differentiation. Okay, so not applicable here. Then the third part, you check it carefully. If you differentiate this and you obtain the expression of velocity and acceleration, you will find that acceleration depends upon the time. Since acceleration is dependent upon the time, so here also we cannot use all these equations of the kinematics for the constant acceleration. Let us check this one. If you differentiate it, v is equal to d by dt of x, the answer will be 15t square, and acceleration will be equal to 30t. Acceleration is dependent upon time. As the time is changing, the acceleration is changing. So we cannot use the equations of the constant acceleration. If you want to solve anything related to these kind of expression, you can use the differentiation or integration. Next, if you differentiate this velocity, d by dt of v, answer will be minus 5, and acceleration here comes out to be constant. Since acceleration is constant, you can easily use the equations of the kinematics for constant acceleration. Going further, looking at this v, I'll be using this formula. Acceleration is equal to v dv by dx. V is actually root x, and can you obtain dv by dx? Do it quick. dv by dx is actually 1 by 2 root x. You can do the calculations and check. Here acceleration comes out to be 1 by 2, which is constant. And if acceleration is constant, we can easily use the equations. Next part, here acceleration is already constant, visible 9.8 meter per second square. This acceleration is constant. It is not changing with the time. Actually, this is acceleration due to gravity. That will be a complete topic. We'll make the video on that. And then the last part, here you can directly see the acceleration is dependent upon the time. If acceleration is dependent upon the time, we cannot use the equations of the kinematics. Note it down, then we'll be taking up the next one. Here you can see few great tips to solve the questions in an easy manner. I request you to pause the video here and note them down. Now taking up the next question, it is regarding the bulletproof glass. I request you to pause it here and then give it a try yourself. It's a simple one. Okay, I'm starting the calculations. As we have already seen the tips for solving the question, first of all, we'll choose the convenient direction. So here I'm choosing this direction as positive and this as the negative. Okay, and then I'll be using the equations of the motion because the acceleration is constant. So we are using v square is equal to u square plus 2a into delta x, the third equation of the motion. After crossing one sheet, the velocity becomes 0.9 u. It's given in the question. So the v square can be written as 0.9 u square. U square is u square only plus 2. Here the acceleration is negative because when the bullet is going in this positive direction, the retardation, the acceleration is in this direction. Okay. So minus sign, and here instead of delta x, I am taking up the thickness t. I hope you understand this thing. Okay. From this calculation, you can obtain the value of 280. 280 will come out to be u square minus 0.81 u square. Simplify it. Then it will be 0.19 of u square. Keep it. We'll require it in the next part of the calculation. Now, in the next part of the calculations, if you use such n sheets together, then this thickness will become nt. The bullet will have the speed here u, but here the bullet will come to rest. The final velocity will become 0. For this situation also, I am using the expression again. The final velocity is 0. The initial is u plus 2. Here also the acceleration of the bullet is directed in this direction, because when the velocity and acceleration are opposite, then only the bullet will slow down. So 2 minus a, and here we should write nt. Do you agree? Now in this expression we can write u square is equal to 2at multiplied with the n. 280 is already available, so I am submitting that value here. U square is equal to 0.19 u square multiplied with the n. From this computation we can obtain the value of n. N comes out to be 1 upon 0.19. Okay. Now how to compute it faster? If it was 1 upon 0.20, what will be your answer? 1 upon 0.20, the answer will be 5. But this data is less than 0.20, means your answer will be greater than 5. So you can take for your answer the n must be 6. You can do the computation. This will come out to be around 5.26. Then at least minimum 6 sheets are required to make the glass bulletproof. Getting it? Simple and easy question. Note it down. Then we'll go further. Here is a simple but nice question. Using the proper sign convention and third equation of motion, you can obtain your answer. So I request you to pause the video here and give it your best shot. I am waiting for your answers in the comment box. Okay, I hope you are done with your calculations. Before starting the solution, we choose the proper sign convention, the direction. So this direction we are choosing as positive and this one we are taking as negative. I am starting the solution here. First of all, we'll talk about the case 1. In case 1, the bullet is finally stopping in the iron. So when the bullet is inside the iron, for that interval we are using the third equation of motion. The final velocity of the bullet inside the iron is 0. Okay, the initial velocity is v and acceleration inside the iron will be written as minus a2 for this bullet, because bullet's velocity is in forward direction when it was piercing through the iron, but the acceleration was in this direction and the displacement was 1 centimeter. Let's call it equation number 1. Is it okay? Now, when the bullet was moving through the wood, let's use the third equation of motion. according to the diagram, the final velocity of the bullet inside the wood is v. The initial velocity is u plus 2. Acceleration will be minus a1, and it travels through a distance of 4 centimeter. Equation number 2. Getting it? Now we'll go for case 2. For case 2, the bullet is finally stopping inside the wood. So first we'll write the third equation for the bullet when it is in the wood. The final velocity is 0. The initial velocity we consider as v plus 2. Inside the wood, the acceleration is minus a1. And how much distance it is traveling inside the wood? 2 centimeter. Call it equation number 3. Is it okay? Now we are writing the equation for the iron. The bullet gets the final velocity v inside the iron, and the initial velocity was u plus 2. Inside the iron, the acceleration is a2 for the bullet, but the sign will be negative, minus a2, and the bullet is traveling what distance inside the iron? 2 centimeter. Okay, let's call it equation number 4. Now you can simplify all these equations and can post your answer in the comment box. Do it quick. I hope you have solved all the equations. When we solve the equation 1, 2, 3 and 4, what you will get? You will get 2a1 is equal to a2. Here is one good thing to note. For iron, we have separately used the equation. For wood, we have separately used the equation. Why not we consider the iron and wood all together and just use a single equation? The answer is simple. The acceleration of bullet is different in iron and different in wood. Acceleration of bullet is constant in iron. Acceleration of bullet is constant in wood. So these equations are applicable individually for the iron and wood. But the acceleration of bullet is not constant for the iron plus wood system. So for iron plus wood system, we cannot directly use the equations of the kinematics. Although individually for them, we can use the equations. Getting it? Note it down, then we'll take up the next one. Here is the next brilliant question. It's an important one, has been asked in numerous examinations. So if you wish, you may pause here and give it a try. I hope you got your answers. So I'm starting the calculations on the board. For starting the solution, we are taking this direction as the positive. And the concept is simple. The pickpocket will get caught at the moment when the pickpocket and the policeman has the same position. You get it? Let's check the solution. As we had the tips that for starting the solution of all these questions, we should imagine the diagram. We should draw a diagram. So I'm doing that here. T is equal to 0. X is equal to 0. Let's say our policeman is here. And at T is equal to 0, the pickpocket is at x is equal to d. Pickpocket is d meters away. So this is the pickpocket. Now we assume that pickpocket gets caught at time t. So making another diagram at time t. Let's say that pickpocket reaches here at time t and that policeman catches the pickpocket. Okay. Now calculation is simple. We imagine that policeman has traveled up this distance. We designate this distance by S police. And that pickpocket has also traveled some distance. We designate this as S pickpocket. Okay. Concept is simple. In order to catch the pickpocket, how all these distances must get related? Actually, S police should be equal to D plus S pickpocket. Do you agree? This policeman catches the pickpocket here at time t. So policeman has covered this initial gap d as well as the distance traveled by the pickpocket. Done. Now putting up the values, policeman is always going with the constant velocity v, so it will travel a distance vt in time t. It's a unidirectional motion, so I'm not bothering about any sign, any vectors. All the sign will be same. D plus S pickpocket, it is starting from rest. We are using the second equation of motion, ut plus half at square. Okay, it is a quadratic equation in time. So rearranging the terms, we can write this as a by 2 t square. This vt I am shifting here, minus vt plus d is equal to 0. You remember how to take up the roots of a quadratic equation. This 2 is getting cancelled out. Is it okay? Now the moment of time cannot be imaginary. The t should be real. If t should be real, then this term should be greater than equal to 0 inside the bracket. I am doing that computation here. For t to be real, this term we are talking about, v square minus 2ad should be greater than equal to 0. And here is our answer. V should be greater than equal to root 2ad. Simple thing. We have proved the first part of the question. If the policeman runs with this velocity, either equal to root 2ad or greater than root 2ad, then it will catch the pickpocket. Now doing the calculation for the second part, we need the maximum time. So from here, I'll choose only the positive sign. So the t max will be equal to v plus root of v square minus 2ad divided by a. Do you agree? And in this expression, we need to put v is equal to root 2ad for maximum time. Why? If the policeman is running at a speed greater than root 2ad, means policeman is running faster and faster. If it is running faster and faster, then time taken to catch the pickpocket will be less. So for maximum time, we should choose the least speed of this policeman, which is equal to root 2ad. Okay, here is the shortest of the space, so I request you to put v is equal to root 2ad here. I am doing the direct calculation. Here is v square. V square is actually 2ad, so 2ad and this 2ad will get cancelled out. This part will get nullified. So you will be left with root 2ad divided by a. It gives me the impression that t max will come out to be root of 2d divided by a. Check it carefully. Do you get the same answer? Okay. So this is all about this question. Interesting and nice one. If you have any doubt, you can post in the chat box. I'll reply. It's a simple question based on the formula S nth is equal to u plus a by 2 2n minus 1. So if you wish, you may pause and give it a try. I'm waiting for your answers. Okay. I hope you got your answer. Solution is pretty simple. We'll be using this equation S nth is equal to u plus a by 2 2n minus 1. So here is the S nth, which is equal to 0 plus a by 2 2n minus 1 divided by S n plus 1. This is given in the question. Here is 0, acceleration is a by 2. This we write as n plus 1. Simple calculation. Let's do the computation. It will come out to be 2n minus 1 divided by 2n plus 1. Okay. You can choose the correct answer. Note it down, then we'll be taking up the next one. Here is the next question, and good one. Pause here and give it a try. we need the displacement of the car in the time interval 2.7 second to 3.7 second. So which formula we can use as the acceleration of car is given as constant? Okay, the solution I am writing here will be using this formula S nth is equal to u plus a by 2 2n minus 1. We need the displacement in the time interval 2.7 second to 3.7 second. It means here I can put n is equal to 3.7. Think about it. U is given as 30. We are choosing this direction as positive. Acceleration is 2. N is 3.7 and then minus 1. Simple computation. It will come out to be 36.4 meter. Okay. Note it down. We already had the talk that n here can be integer or can be fraction. There is no issue with that. Done? Let's go further then. Here is another simple question. Acceleration is constant, so we can use the equations of the motion and we need to find the height of the tower. Give it a try. Okay, I'm starting the solution here. As usual, we'll choose some direction positive. So this time I'm choosing the downward direction to be positive. This depends upon us. Suppose the last second we assume as the nth second, and we can use this formula S nth is equal to u plus a by 2 2n minus 1. Okay, because acceleration is constant. In the last second, we know that displacement is 45 meter. U is 0 as the ball was just released. Acceleration is 10 divided by 2 and 2 into n minus 1. Simple computation. Simplify it and will come out to be 5. So at 5th second, it will be traveling the 45 meter. Means from t is equal to 4 second to t is equal to 5 second time interval, it will travel a distance of 45 meter. Now we need the height of the tower. Assume that height of the tower is h, and then we are using again the second equation of motion. The ball will cover the total height h in how much time interval? 0 to 5 second. So h is equal to 0 into 5 plus half into 10 into 5 square. This equation I am using for the journey of the ball from t is equal to 0 to t is equal to 5. The ball will cover up a distance h, time taken is 5 and acceleration due to gravity is given as 10. Simplifying it, h comes out to be 125 meter. So the height of the tower is simple 125 meter. Okay. Although this question can be solved without using the equations, just looking at the question, you can answer it. That we will do in another video, the free fall. Okay. Till then, you note down this solution. The next question, we know that a particle has the constant acceleration. Its displacement in the 4th second and 5th second is given to us, and we need to obtain its displacement in the 6th second. It's a simple one, so you can give it a try. I'm starting the solution here. We can use which equation of motion? Correct. S nth, displacement in the nth second, is equal to u plus a by 2 2n minus 1. Okay. Now, we know that displacement in the 4th second is given to us as 10 meter. So 10 is equal to u plus a by 2, 2 into 4 minus 1. Clear? Then we know the displacement in 5th second, that is given to us as 14 meter, which is equal to u plus a by 2, 2 into 5 minus 1. We'll call it equation number 1 and this is equation number 2. Now, from equation 1 and 2, you will get the value of two unknown variables. We have two equations and two unknown variables. Here a is unknown as well as u is unknown. So on solving equation 1 and 2, we will get the value of u as well as the value of a. Can you tell me the values of u and a by solving these equations? Give it a try and post your answer in comment box. Okay, on solving these equations, you'll get a is equal to 4 meter per second square and u is equal to minus 4 meter per second. Okay, now we can easily obtain the last answer, that displacement in the 6th second. It will be equal to u means minus 4, acceleration means 4 by 2, 2 into 6 minus 1. Simplifying it further, you'll get your answer as 18 meter. Simple and easy question. You can note down the answer and then we'll go further. Here we have a pretty simple question, simple formula based question. So I request you to pause the video and give it a try yourself. I hope you have proved the answer. So I'm starting the solution here. If we look at the language of the question carefully, what we know the initial velocity as the dart is starting from rest. We know the final velocity which is given as v, and we know that acceleration of the dart is constant. If acceleration is constant, we can easily use the equations of motion. Okay, which equation we should use? Speak up. We should be using the second equation in this format, s is equal to u plus v by 2 into t, because our requirement is the time t. The s is actually equal to L. U means the initial velocity of the dart. Initial velocity of the dart is 0. It is starting from rest. Final velocity of the dart is v divided by 2 multiplied with t. T is our target. So t comes out to be 2L by v. Simple question and easy proof. Got it? Note it down. Then we'll be taking next one. Here is the next question. If you wish, you may pause the video and give it a try and then post your answer in the comment box. It's a simple question. I hope you got your answer. Let's start the calculations. Our trick says that first of all, we should imagine the diagram. So here lies the diagram for the situation. This motion has two different segments. For the segment 1, the initial velocity is 0 and the acceleration is 2.6 meter per second square. And in the segment 1, the displacement is 120 meter. Looking at this data, which equation of motion we can use? Correct, third equation of motion. Then we'll get some velocity at the end of segment 1. That velocity will serve as the initial velocity for the segment 2. Getting it? So I'm starting the solution. First of all, let us simplify it for segment 1. Okay, I'm using the third equation of motion. The final velocity we don't know, we call it v. The initial velocity is 0 as the bike is starting from the rest, plus 2 into acceleration is given as 2.6 and the displacement is 120. We call it equation number 1. Simple. Now we are going for segment 2. For segment 2 again we'll be using the third equation of motion. The final velocity for the segment 2, reading the language, we know that 12 meter per second square. The initial velocity for the segment 2 will be actually equal to v. Remember that, plus 2 into acceleration for the segment 2 will be taken as negative according to the language of question, and it is minus 1.5 meter per second square, and we require the displacement in this segment. That displacement, let's say we are indicating by S. Can you simplify these equations? From equation 1, you can put the value of V square. Do the computation quickly and let me know what you are getting for S. S will come out to be 160 meter. You can note it down. Here is the next question. A particle starts from rest and its acceleration is constant. In the time interval 5 second to 15 second, it travels a distance of 150 meter. Then we need to find that how much distance it will travel in the initial 10 seconds. Got the question? If you wish, you may pause here and give it a try. I'll wait for your solutions, for your answers. Okay, let's proceed for the solution. Question is pretty simple. Since it is starting from rest, its initial velocity will be 0. And since acceleration is constant, it will keep on moving along the straight line and it will never ever turn back. So the magnitude of displacement and the distance traveled for any time interval will be equal. Getting it? Let's draw the diagram for starting the solution. Suppose t is equal to 0, the particle has the position x is equal to 0 and its acceleration is constant, u is given as 0. Then here is the moment t is equal to 5 second, somewhere here is the moment t is equal to 15 second. From 5 second to 15 second, it travels a distance of 150 meter. That's given in the question. So what we can do, from t is equal to 0 to t is equal to 15 second, this distance I am writing as S15, okay. And then from 0 to 5 second, this I am writing as S5. Now how we can write that 150 meter? Simple. 150 meter will be actually equal to S15 minus S5. What is S15? Displacement or the distance traveled in the time interval 0 to 15 second, and similarly S5 is the displacement or the distance traveled in the time interval t is equal to 0 to 5 second. So I am putting up the values. S15 will be equal to what? Ut plus half at square. U is 0, time is 15 plus half a into 15 square. Okay. S5 will have the similar format. U is 0, time is 5, acceleration is a, and multiplied with the 5 square. Computing this will get the value of the acceleration. Do your calculations quickly. You will obtain the a. A comes out to be 3 by 2 meter per second square. Check it once. Now, if we know the acceleration, we can easily find the displacement or the distance traveled in the initial 10 seconds. Let's say somewhere here is the moment t is equal to 10 second. And now you need this thing. I'll indicate it here by S10. Can you obtain S10? I'm doing the calculation here. S10 will be equal to 0 into 10 plus half into 3 by 2 into 10 square. Understand that? Simplify it further. S10 will be equal to 3 by 4 into 100 meter. So it will come out to be 75 meter. Simple answer. Okay. This S10 is what? The displacement or the distance traveled for the time interval t is equal to 0 to 10 second. Okay, note it down, then we'll go further. Here is the next question. A car is moving with constant acceleration. We need to find the velocity of the car at the midpoint as shown. Getting it? Using the third equation of motion, you can immediately get your answer. If you wish, you may pause the video here and give it a try. Okay, I hope you are done with your calculations. So let's check them. For solution purpose, we are choosing this direction as the positive and will be using the third equation of motion. So for first half of the motion, I am using the third equation. Looking at this diagram, I should write v square is equal to v1 square plus 2a d by 2. Do you agree? Let's call it equation number 1. For second half of the motion, we can write similar equation using the third equation of motion. We should write then v2 square is equal to v square plus 2a d by 2. Do you agree? Simple computations. I am subtracting these two equations. By 1 minus 2 in LHS, we are left with v square minus v2 square, and in RHS, we are left with v1 square minus v square. This v square we can shift here and this v2 square we can shift there. On simplifying everything, you'll get the final expression of v. V will come out to be root of v1 square plus v2 square divided by 2. Check it once. Simple and easy answer. Note it down. Then we'll be taking up the next question. Here is the next question and it's a simple one. You may pause the video here and give it a try yourself. Okay, I hope you are done with your calculations. For starting the solution, we'll assume the up the inclined direction is the positive, and we can use the equations of the motion as acceleration is given as constant. One relation is given in the language of the question that acceleration of A is 3 by 4 the acceleration of B. If acceleration of A is less as compared to the acceleration of B, it surely indicates that time taken by the A to reach at the top will be greater than the time taken by the B. So if A and B start at the same moment, then A will reach late as compared to B at the top. Getting it? But the question is asking how much early the A should start so both can reach at the same time. Can you think? It's simple logic. Suppose A is taking 25 seconds to reach at the top and B takes 20 seconds to reach at the top. Then A should start 5 seconds earlier than B. Think about it. In that way we can get our answer. So actually our answer will be equal to TA minus TB. If we can obtain this, our task is done. Now I am doing the calculations here. Let's say both are covering the same distance S. I am using the second equation of motion. S is equal to ut plus half at square for particle A as well as B. U is 0 for both. So it will look like this. Both are having the same displacement up the incline. So from this expression, we can get a relation. At the place of A, I am putting 3 by 4 AB TA square is equal to AB TB square. The AB is getting cancelled out. So TA by TB comes out to be 2 by root 3. And then TA comes out to be 2 by root 3 TB. Is it okay? Putting up the value of TA here, 2 by root 3 TB minus TB. Done. So this answer will come out to be 2 minus root 3 divided by root 3, and the value of TB is given as 5 minutes. That should be our answer. Simple computation. You may note it down, then we'll go further. Here is the next question and it's a simple one. the person is starting from rest with the constant acceleration, while as the cycle is always moving with the constant velocity of 4 meter per second. Then we need to find at which moment of time the person will cross the cycle. Okay, give it a try. Then I'll be simplifying it on board. Okay, I hope you are done with the calculations. The concept is simple for all such question. Wherever the question has been ended, we should start from there. The question says when the person will cross the cycle, then you should start your solution with this statement. Let's say the person crosses the cycle at time t. Getting the idea? And then draw a diagram, use the tips and tricks and do the calculations. So I am starting the solution here. Let us assume that the person crosses the cycle at time t. Okay, now I am making a diagram. T is equal to 0. The person was here and the cycle was here. Distance between them was given as 12 meter. At time t, the person and the cycle, they are crossing each other. So the diagram would be kind of this. Done. Now for this situation, the person will travel some distance that we indicate as SP, and the cycle will travel some distance that we indicate as SC. What should be the relation? Simple, you can see it from the diagram. SP must be equal to 12 plus SC. Okay, this person has the constant acceleration and it is starting from rest. So SP will be written using the second equation of motion. UT plus half AT square is equal to 12 plus SC. Cyclist is always moving at a constant rate of 4 meter per second. So SC will be speed into time. Done. We can simplify this expression. It's a quadratic in time. T square minus 4t minus 12 is equal to 0. You know how to solve such quadratic. When you simplify, you'll get 2 moments of time. T is equal to minus 2 seconds and t is equal to 6 seconds on solving this quadratic. Since the motion started at t is equal to 0, so we are discarding this solution and will consider this as the correct answer. So at t is equal to 6 seconds, the cyclist and the person will be at the same position. The person will cross the cyclist then. Okay. Note it down, then we'll go further. Here is another beautiful question on the same pattern as the previous one. So I request you to pause the video and give it a try yourself. Okay, I hope you are done with your calculations. I am starting the solution here. Using our tips and tricks, first of all, we'll assign the positive direction. So this we are choosing as the positive direction. Okay. And then we start the question where the question setter has left the question. This question is asking when the boy will cross the bus or vice versa. The bus will cross the boy. Getting it? So we'll assume that let boy crosses the bus at time t. Okay, and then we'll make a diagram at time t. If the boy is crossing the bus, it means the bus and the boy should be at the same position at time t. Okay, so initially let's say at t is equal to 0, the boy was at x is equal to 0. Boy is always moving with a constant speed of 9 meter per second. At t is equal to 0, the bus was here and the bus starts from rest. Its acceleration is constant, 1 meter per second square. Getting it? Its u is 0. So the boy has traveled this much distance. We assign this as S boy. And the bus has traveled this much distance at time t. This is the picture. If the boy is crossing the bus, it means the S boy should be equal to 40 plus S bus. Do you agree? Distance traveled by the boy should be equal to this initial gap plus the distance covered by the bus in time t. S boy we can write easily. Its speed is constant. So S boy is speed into time. Acceleration is 0 for the boy. 40 plus S bus will be written as ut plus half at square. U is 0. Acceleration is given as 1. It is constant. So we can use the equations of motion and t square. Again, it's a quadratic equation in time. So can we simplify this? I'm leaving it to you. You do the calculations. On doing the calculation, you will get two roots of time. T is equal to 8 seconds and t is equal to 10 seconds. Now, what is the significance of these two roots of the time? If you pay attention, at t is equal to 0, bus is starting from rest. And at t is equal to 0, the boy already has some velocity. So, for some moments of time, the bus is moving slower as compared to this boy. So what will happen at t is equal to 8 seconds, since the boy has a greater speed as compared to the bus, the boy will cross the bus. Keep in mind, t is equal to 8 seconds, the boy will cross the bus. But the bus is continuously accelerating. So there will come a moment when the speed of bus has been greater as compared to the speed of the boy. So boy is running at its own speed and there will come a moment when the bus will cross the boy. That is t is equal to 10 seconds. Getting it? Pause the video here and think about these statements. T is equal to 8 seconds, the boy crosses the bus. T is equal to 10 seconds, the bus crosses the boy. And after that, the bus has greater speed, so it will keep on moving away and away from the boy. They will never cross each other. Okay? Note down, it's a great question and I request you to give it a try again yourself. You'll learn nice concepts. Here is the next question and it's a brilliant one. It's the extension of that previous question. We know that at t is equal to 8 seconds, the boy will cross the bus, and at t is equal to 10 seconds, the bus will cross the boy. The question is asking to find the maximum separation between the boy and bus in the time interval t is equal to 8 seconds to 10 seconds. It's an interesting one, so I urge you to pause here and give it your best shot. There is a good learning in this question. Okay, I'm starting the solution here. First of all, we'll draw a diagram so we can understand the situation easily. And I'm drawing two separate diagrams. We know the moment t is equal to 0, the boy was here. Its speed is 9 meter per second, which is constant. And t is equal to 0, the bus was having the initial speed 0 and its acceleration was 1 meter per second square. That data is given in the question. Then there come the moment t is equal to 8 seconds somewhere here. At t is equal to 8 seconds, the boy reaches here. Its speed is yet 9 meter per second constant. And at t is equal to 8 seconds, how much will be the speed of that bus? We can easily simplify. Acceleration is 1 meter per second square. What does it mean? Every second, the speed increases by 1. So starting from t is equal to 0, at t is equal to 8 seconds, every second, if it is increasing by 1, 1, 1, so at t is equal to 8 seconds, the speed of the bus will be 8 meter per second. Is it okay? acceleration of bus is constant given to us, so we can use the equations of motion very easily. Now, if we observe at this moment, the speed of bus is 8 meter per second, the speed of boy is 9 meter per second. It means just after this moment, if you are going to check for some time interval, the boy is moving faster. If it is moving faster and the bus is comparatively moving slower, so the distance between them will increase. Getting it? So let's say we draw the diagram for that scenario. After some time, the boy reaches here, and this time I consider as, let's say, capital T, and the bus reaches here only. Okay, in time capital T, the bus goes from here to here, while as the boy goes from here to there, because it's moving faster as compared to the bus. Now we can obtain the separation between the boy and bus. This is the separation between boy and bus. Getting it? In order to obtain that x, I should subtract this distance from this one. Do you agree? So x will be equal to, see, the distance traveled by the boy here will be 90, and the distance traveled by the bus here will be ut plus half at square. Is it okay? And we need to maximize this distance. So let us simplify it first. 90 minus 80 will give you t minus t square by 2. Is it okay? For maximum value of x, which concept we can use? Correct? d by dt of the x should be equal to 0. Here this time t is the variable, so we are differentiating with respect to it. Let us do the computation. d by dt of x, x is this, t minus t square by 2, this should be equal to 0. This differentiation I am doing here. D by dt of t, this will become 1, minus differentiation of t square will be 2t, and that 2 is already here, it's a constant, so it's taken outside of the differentiation, is equal to 0. So t comes out to be 1 second. T comes out to be 1 second, and if you observe from the starting, then this moment will be actually t is equal to 9 second. Getting it? The bus is here at t is equal to 9 second, the boy is here at t is equal to 9 second, and then separation between them will be maximum. Now we can easily obtain the value of x max by putting up the value of t here. X max will be equal to 1 minus 1 square by 2, which is equal to 0.5 meter. So for the asked time interval, the maximum separation between the boy and the bus will be 0.5 meter. Getting it? You may note it down. It's a nice question. Then we'll go further. Here is the last question of this video, and it's family pack. There are varieties of the questions involved in this one. So I urge you to pause here, pay attention to each and every part, and then give them your best shot. Take your time. Okay, let's start the solutions. I hope you have noted down all the questions. First of all, we'll assign the sense of directions. So this we are choosing as positive and this we are taking as negative. And t is equal to 0. The particle has the initial velocity 5 meter per second. This position we consider as x is equal to 0. The acceleration of the particle is constant, which is given to us as 2 meter per second square. Since velocity and acceleration are in opposite direction, so particle has to slow down. First question is asking that when the particle will stop momentarily. This can be done using the equation or this can be done directly. First I am doing it directly. What is the meaning of 2 meter per second square? 2 meter per second square should be read as 2 meter per second every second. Do you get this? So its velocity will reduce by 2 meter per second every second. It means if I ask you what is the velocity at t is equal to 1 second, what should be your answer? In 1 second velocity will reduce by 2 meter per second, so it will become 3 meter per second. Do you get it? If I ask you what is the velocity at t is equal to 2 second, what should be your answer? Again it will reduce by 2 meter per second in 1 second. So the remaining velocity here will be 1 meter per second. Okay. And in 1 second, if the velocity is reducing by 2 meter per second, then in half second, velocity will reduce by what amount? 1 meter per second. So in next half second means this is the moment t is equal to 2.5 second. The velocity will become 0 momentarily. Okay. Now the same answer you can obtain using the equation of motion. Which equation we should use? We know that final velocity is 0. We know the initial velocity. So I should use the first equation of motion. V is equal to u plus at. This direction has been chosen positive. So u will be written as plus 5. Acceleration will be written as minus 2 because acceleration was in this direction. And t is unknown. T comes out to be 2.5 second. Same answer. So it is your choice. You use the equations or you do it direct. If you want to save your time in examination, I am recommending you to do few questions directly. Okay, with practice, you can do all these calculations in the air. You need not use the equations. Done? Note down the first part of the solution. Then we'll go to the second part. Now solving the second part of the question, we need to find the displacement of the truck till it stops momentarily. It stops momentarily at t is equal to 2.5 second. So we should use which equation for solving the second part? Actually, you can use any format of the second equation of kinematics. Either you can use s is equal to ut plus half at square, or even you can use s is equal to vt minus half at square, or if you wish you can use s is equal to u plus v by 2 into t. Any equation will give you the same answer only. See the calculation. U here is 5, time is 2.5 plus half, acceleration is minus 2 because acceleration is in this direction, and the time is 2.5 whole square. Can you compute it? It's simple calculation. Answer will come out to be 6.25 meter. Check it. Now I'm using this equation and it will also give us the same answer. S is equal to Vt. V is the final velocity. Final velocity here is 0. Time is 2.5 minus half. Acceleration is how much? Minus 2. And time is 2.5 whole square. Answer again comes out to be 6.25 meter. Done. Okay, using that format, S is equal to U. U is available to us 5. V is 0 by 2 and time is 2.5. Getting it? S comes out to be 6.25 meter. So you can use any format of the equation as per your conveniency. Your answer will come out to be same. Done. Play with the equations. You'll learn a lot. Note it down. Then we'll go for the third part of the question. Now let's talk about the third part of the question, the displacement in the initial 5 seconds. The answer to the third part can be directly written that displacement will come out to be 0. Why? In the initial 2.5 second, it reaches here and stops momentarily. And since acceleration is constant, it will go back, okay. And then in next 2.5 second, it will reach back here. So the displacement will become 0. Although I can prove it with the equations. S is equal to ut plus half at square. U is 5. Time is 5. Acceleration is minus 2 in this direction. So minus 2. Time is 5. Simplify this. Displacement comes out to be 0. Whenever the acceleration is constant, the forward motion and the backward motion, they are symmetric. Using that symmetry, you can tell in the initial 2.5 second, if it has traveled 6.25 meter, then in the next 2.5 second, it will again travel back here 6.25 meter. Getting it? You can note it down. And if you wish to plot the diagram, then you can tell that at t is equal to 5 seconds, the truck will be again here. And at that moment, acceleration is 2 meter per second square and its velocity will be now in this direction. Speed will be 5 meter per second only, okay, and the displacement will become 0. This position we have considered as x is equal to 0. Note it down, and then we'll go for the fourth part. The fourth part is asking the distance traveled in the initial 5 seconds. It's simple. For the 2.5 second, it is traveling a distance of 6.25 meter in forward direction. And then for next 2.5 second, it's coming back and traveling the same distance. So the answer to the fourth part is pretty simple. Answer will be 6.25 plus 6.25 meter, which will be equal to 12.50 meter. Okay. Actually, from here, the particle will return back on the same line. Just for sake of simplicity, we are showing it here on the other line. Done. Why this answer is greater as compared to the answer in the third part? Can you tell? Actually, here particle is turning back. Whenever the moving particle turns back, the distance traveled will always be greater than the magnitude of the displacement. Okay. Note it down. Then we'll go for the fifth part. The fifth part is asking the displacement in the t is equal to 0 to t is equal to 7 seconds. Without doing the calculation, can you tell your answer will be positive, negative or 0? Anyone can tell. If this was t is equal to 0 moment, the t is equal to 7 second moment, the particle will be to the left side of the origin. So the displacement must come out to be negative. Getting it? Now I am proving that fifth part. S is equal to ut plus half at square. How much is u? U is 5, time is 7, acceleration is minus 2 and the time is 7. This is getting cancelled out. So we are left with what? 35 minus 49. It means what? Minus 14 meter. What this negative sign indicates? That the particle is to the left of the origin. Clear? Note it down. Then we'll go further. Now comes the sixth part. In sixth part, they are asking the distance traveled in the time interval 0 to 7 seconds. Actually, without calculation, you can tell that the distance traveled will be greater than the magnitude of the displacement in the same time interval because particle has turned back. Now, looking at the diagram, you can answer it directly. From t is equal to 0 to t is equal to 5 seconds. How much is the distance traveled? we have already obtained, that was 12.50 meter. And the next 2 seconds, how much is the distance traveled? Think logically. Using this answer, you can tell it will travel 14 meter in this direction. So plus 14 meter. Here comes your final answer, 26.50 meter. Can we use that formula S is equal to ut plus half at square for these calculations directly? No. That formula is for displacement. And here we are calculating the distance traveled. And since particle is turning back, so the magnitude of displacement is not equal to the distance traveled. Getting it? That's why we are calculating the distance traveled using such diagrams. Note it down, then we'll go further. Now let's talk about the 7th part. It's a brilliant question. Question is asking the distance traveled in the second. Distance traveled in the second means what? Actually, the distance traveled in this time interval from t is equal to 1 second to t is equal to 2 seconds. This is the distance traveled in the second. Okay. Now, if we look at this motion, for this time interval, the motion is unidirectional. There is no turning back. It means the magnitude of the displacement and the distance traveled will be same. And we have a formula for the displacement. So I can use that directly here. Clear? Let's go for the calculation. S nth is equal to u plus a by 2 2n minus 1. Although it is a formula for the displacement, but here we can use it for the distance traveled because the magnitude of displacement and the distance traveled for this time interval is equal, is same. Done. Put up the values now. U was 5, acceleration was minus 2 divided by 2 into what you will put n. Distance traveled in the second we require, so n will be 2 minus 1. It's a simple calculation. 5 minus 3, so the answer comes out to be 2 meter. Getting it? If someone asks you how much is this distance, now you can easily reply this distance is 2 meter. Ask if you have any doubt. Note it down. Then we'll go for the 8th part. Now let's talk about the 8th part. Now we need the distance traveled in the 3rd second. It's brilliant question. During the 3rd second interval, there is a turning back. So can we use the formulas of the displacement for the calculation of distance traveled? Answer quickly in comment box. We cannot use the formulas of the displacement for the 3rd second time interval for calculation of distance traveled because there is a turning back. So in the 3rd second moment, the distance traveled will be actually greater than the magnitude of the displacement. Since the motion is symmetric, we know, so here will be the moment, let's say t is equal to 3 seconds while going back. Its velocity will be in this direction. We know one thing, it will have the same speed, so you can write it here, 1 meter per second, and its acceleration will remain 2 meter per second square constant. Getting it? Now we need the distance traveled for this time interval, means this distance is required, this thing. Actually it's traveling on a straight line. It will go like this and then it will return back. But for sake of simplicity, I'm showing it like this. How we can find this distance traveled? If we can obtain this distance, then this and this will be the same and we'll get the answer. And now it is pretty simple. We already know that this total distance is 6.25 meter. Do you agree? We know that this distance is 2 meter. If anyhow we can determine this distance, then we can easily obtain this remaining distance. That I can tell you is equal to 4 meter. How we can find that? Suppose this is the distance traveled in the first second. Okay, how we can find distance traveled in the first second? We know the formula, u plus a by 2, 2n minus 1, where n will be equal to 1. So putting here 2 into 1, value of acceleration is known to us, it is equal to minus 2, and value of u is 5. Let us compute it. 5 minus 1. So answer will come out to be 4 meter. In all these calculations, unit I am writing at last to make the calculations faster. Okay. So this distance is 4 meter, this distance is 2 meter, total distance is 6.25 meter. It means, how much is this distance? This distance is 0.25 meter. And if this distance is 0.25 meter, while coming back, it will again travel 0.25 meter. Then here we get the answer for the 8th question. The distance traveled in the third second will be equal to 0.25 meter plus 0.25 meter, which will be equal to 0.50 meter. Getting it? What is the meaning of the third second? From here, t is equal to 2 second to t is equal to 3 second. That time interval we call as the third second, and this is the distance traveled. What if I ask you the displacement in the third second? What should be your answer? Write it quickly in the comment box. The displacement in the third second. Correct. Answer is your favorite digit. It is 0. I am writing that here. Can you tell the logic? Displacement in the third second is 0. Because from t is equal to 2 to 2.5, it will travel 0.25 meter forward. And then from t is equal to 2.5 to 3, it will travel 0.25 meter backward. Equal forward and backward motion. So the displacement will become 0. Or you can even obtain it using the equation. S third is equal to u. U is 5. Acceleration is minus 2 divided by 2. And 2 into 3 minus 1. Check it. This will come out to be 0. Okay. Brilliant question. Fine. You note it down, and if you have any doubt, pause the video, do the calculations yourself very carefully. You'll understand it. Even then, if there is any issue, fire up the chat box. I'll reply. Note it. Then we'll take up the 9th question. Now, 9th question is a piece of cake for everyone. You need the distance traveled in this time interval. Anyone can easily tell, as the motion is symmetric. This is 2 meter, this is 4 meter. So answer is 6 meter. I hope you get it. Simple one. No equations are required. Directly you can simplify it. Note it down. Then we'll go for 10th. Now solving the 10th question, we need to find the moment of time at which the displacement is positive 4 meter with respect to the origin, with respect to the starting position. What is your answer? It's simple actually. The answer will be 1 second as well as 4 second. How? The motion is symmetric. At t is equal to 1 second, it is having a displacement of positive 4 meter with respect to the origin. Then it will go there and then it will come back. T is equal to 4 second. Entire motion is symmetric. We had that talk. And its velocity will be like this. Acceleration is already constant, 2 meter per second square. Do you agree? Although if you are not satisfied with the diagram, we can go with the maths, we can go with the equation. The displacement is positive 4 and we need the moment of time. So I am using the second equation, S is equal to ut plus half at square. S is positive 4, U is 5 into T, T is let's say unknown, plus half, acceleration is -2 backward direction, and T is unknown. So here we have a quadratic equation in time. Let us simplify that quadratic equation. The format will look like what? T square minus 5t plus 4 is equal to 0. We can simplify this. T square minus 4t minus t plus 4 is equal to 0. I hope you remember how to solve such things. Here I am taking t common. So it will be t bracket t minus 4. For this part I have done the computation. Then I am taking minus 1 common here. Then minus 1, and it will be t minus 4 is equal to 0. Simplifying this, t comes out to be 1 and t comes out to be 4. Okay. Simple question. Note it down. Might be few of you got a single answer. Actually, this situation will have two possible answers. You remember the moment where I told the tips to solve the kinematic question. The different answers correspond to the different physical situations. T is equal to 1 second is the situation when the truck was going forward, and T is equal to 4 seconds is the situation when the truck is coming backward. At both instances of the time, the displacement is positive 4 meter with respect to the starting position. Okay. Note it down. Then we'll go for the 11th question, and that is a great one. Now the 11th question, super important. Before we start the solution, can you tell me how many answers you will get for the 11th questions? Number of possible moments of time. Post it quickly in the comment box. There will be how many moments of time as the answer of the 11th question. The first correct answer will get 1 kg BIKANERI BHUJIA. Post it quick. Okay, actually there will be 3 moments of the time. Read the language very carefully. Particle is 4 meter away from its starting position. Particle can be 4 meter away in the positive direction, as well as particle can be 4 meter away in the negative direction. Getting it? And when the particle is 4 meter away in the positive direction, those instances we have already solved. Clear? So I am writing the answer here. We need to solve only this instance when the particle is 4 meter away in the negative direction. So there will be 3 answers. First answer is t is equal to 1 second. It's already visible on the diagram. At t is equal to 1 second, particle is 4 meter away from the origin. Even at t is equal to 4 second, particle is 4 meter away from the origin. And the last and the third answer, t is equal to 5 plus root 41 by 2 second. At this moment of time also, the particle will be 4 meter away from the origin, although in the negative direction. See, 5 plus something, getting it? Root 41 will be how much? Root 36 is 6. So root 41 will be greater than 6. So greater than 6 plus 5. Something greater than 11. Something greater than 11 by 2. So time is beyond 5.5 second. And actually beyond 5.5 second, particle will be in the negative direction. And for that instance also, it can be 4 meter away from the origin. And after that, it will keep on moving away and away. So how to obtain this answer? It's pretty simple. When particle is 4 meter away in this direction, then its displacement will be positive or negative? It will be negative. I am using second equation of motion. S is equal to ut plus half at square. The displacement is -4. U is plus 5. Time is unknown. Plus half. Acceleration is -2. And t square, which is unknown. Done. Now we have a quadratic equation in time. So it is t square minus 5t minus 4 is equal to 0. You know how to obtain its root. t will be equal to minus of minus 5 plus minus root of minus 5 whole square minus 4 into 1 into minus 4 divided by 2 into 1. Is it okay? I hope you remember all these computations, how to do them. Here we cannot consider this negative sign because we know that the value of time is greater than 5.5 second for this displacement. So I have to discard this negative sign, and then you can simplify. When you simplify, it will come out to be 5 plus root 41 by 2 second. Brilliant answer. So how many of you got all three answers correct? Let me know in the chat box. Before you go away, I would like to tell you another method of solving many of such questions, that is the velocity versus time graph. For this particle, you try to plot the velocity versus time graph, and then you can easily answer many questions. T is equal to 0. The velocity was 5. T is equal to 2.5 second. The velocity becomes 0. This moment is 2.5 second. Actually, we know that V is equal to U plus AT. U was 5. Acceleration was minus 2. Clear? This is depicting a straight line. Y is equal to mx plus c. Here m is negative, c. The slope of this line is negative. The intercept on the y-axis is positive. Here is the intercept on the y-axis, which is positive. Now you can compute many things. Suppose someone asks you what is the velocity at t is equal to 1 second. Put here t is equal to 1. Put here t is equal to 1. You will come to know that velocity at t is equal to 1 second is 3 meter per second. Suppose you need velocity at t is equal to 4 second. Put here t is equal to 4 second. You will come to know the velocity. You need the displacement. Then you can take the area under this curve with proper sign. Area above the time axis is positive. Area below the time axis is negative. If you need the distance traveled, then you consider all the area as the positive. Getting it? So it's up to you. Play with this method. You'll enjoy it. Stay awesome. Take care. Happy learning.